Let's look at the use of the public key infrastructure in electronic commerce. Now, just to review before we start looking at the contents of the packets, what basically happens when you connect to an e-commerce site on the internet, uh, a digital certificate is downloaded. Inside the digital certificate are a number of things, one of which is the public key of the site that you connected to, and it's used by the client, your computer. That public key is used to encrypt the session key, which is sent back to the e-commerce site, and there is the corresponding private key that is used to decrypt the encrypted session key. So now both ends of this conversation have the session key, and that's used to encrypt the rest of the transaction. So it all hinges on the digital certificate that's downloaded from the e-commerce site, from a server at the e-commerce site. So let's look at what's going on here. Now this is a Wireshark capture, and if I go back a little bit, you can see some of the other packets. The actual digital certificate is contained in this packet. In this particular capture, it's packet 274. Notice the source port is 443, which is the socket used by secure websites. And if you double click on this, Wireshark will pull this out for you. Makes it a little bit easier to look at. So this is just that one packet. And let's look around in here and see what we can find. Now, again, this is a little touchy. You have to be careful how you move back and forth, because if you do the wrong thing, you'll lose what you're trying to look at. But notice here there's a field called subject public key, and I've clicked on this, and therefore it's highlighted down here in the bottom. Now, what you see here in the bottom is just a stream of ones and zeros. That's actually the packet contents. Okay. By clicking on something here, Wireshark will show you that particular field in this stream of ones and zeros. Everything you see here in the top window is Wireshark breaking down the different parts for you. So for example, nowhere in here does it say specifically secure sockets layer. We know it's secure socket layers. It's a secure socket layer type packet because of something that's included up here in this part. So what you see at the top is Wireshark helping you break this down. What you see in the bottom is actually what's in the packet itself. But anyway, in this case I've clicked on subject public key info, and what you see highlighted here is the actual public key. And again, remember, a key, public or private, is just a long stream of ones and zeros. So that's what you see there. These are what I'm pointing at here is the hex representation of a long stream of ones and zeros that comprise the public key of JCPenney. And here in this over here, it's actually Wireshark's trying to display the hex as ASCII. So sometimes you can actually see something that makes sense, like the subject to this. If you look carefully through this, some of this actually has translates into ASCII that you can actually read. So I see Plano, Texas. I see the JCPenney Corporation, etc. So hex, ASCII equivalent. Sometimes you can read this, sometimes you can't. But getting back to what we're looking at there, that is the hex representation here of the public key of JCPenney. So here's our problem. We have to have a mechanism that such that the client, us, and our computer can verify that the public key really belongs to JCPenney and it's not being spoofed. Well, here's the way this works. The digital certificate that was downloaded was actually generated by a certificate authority. And if we pick through here, we can find out who that is. What I want to show you right here is this is the signature. So your digital certificate contains a digital signature. And here's how this works. The contents of the digital certificate, which you can look up what's actually in there. It identifies the company whose public key it is, the certificate authority that issued the digital certificate, some version information, some other things. But one of the things it contains is a hash of the entire certificate that has been encrypted with the private key of the certificate authority that issued it. So here's what you see right here. You click on that. This part right here, this stream of ones and zeros, is the digital signature. It's the encrypted digital signature of the hash of the message. Now here's the way this works. We have this encrypted hash, and let's see, this comes from DigiCert, looks like. And here's what we're going to do. I'm going to open up a Microsoft Management Console. Just type MMC and run. Now you can actually get to these, what I'm going to show you here, these certificates, in Internet Explorer, for example. I think this gives you a little bit better view. So notice what I did. MMC just opens up a blank console, a Microsoft Management Console. You go to File, you can add, remove snap-ins. And notice here there's a list of available snap-ins. I'm going to click Certificates, click Add. Now for this one it wants to know, do you want the certificates for your user account, the computer service account, or the computer account itself? I'm just going to leave it on my user account. Click Finish, click OK. So the way the Microsoft Management Console concept works is it gives you a similar look and feel for various tools that you can insert inside the console, which is what I've done for certificates here. And by the way, you can save this with certificates already installed if you wish to. So I expand certificates here for the current user, and there's a big list of things here, and you can play with this. If you've got personal certificates, they'll be under personal, And looks like I have some for iPhone. Uh, and this is one I use for that my computer uses to check my email. This is one that will allow me to encrypt files on this laptop. So those are personal. I'm more interested in some of these. Look at the Enterprise Trust. There's nothing in there. Probably Trusted Root's what we want. So the Trusted Root certificates, if you remember how the public key infrastructure is actually laid out, at the top level there are root certificate authorities, and this is a big list of them. So ours was something to do with DigiCert. I'm not going to go back and look at it particularly, but maybe it's Global Root too. Could be. I'm going to double click on this. Now, by the way, if you're wondering where these come from, there's a certain number of these that are installed when you install your operating system. Also, when you run updates on your operating system, these get updated and added to as needed. So ultimately, all these come from Microsoft. So here is a certificate. This was issued to DigiCert Global. Well, DigiCert. This is their Global Root G2 certificate. You click on details here. Here's everything that's in the certificate itself. And among other things, there's the public key. Notice this is an RSA generated key, and it's 2048 bits. So it's going to be reasonably secure, of course. This is what your computer uses, and here's what's going to happen. You've got, going back to this, here you've got the encrypted hash of the entire message. When your computer receives this message, it uses the public key that we just looked at for DigiCert here. It decrypts this signature. Remember, that signature is the encrypted hash of the message. Then your computer will generate its own hash of the message and compare to the decrypted hash that was contained in the digital certificate. If they match, there's been no changes to the digital certificate, and therefore your computer and you know that there's that the public key included in the certificate is in fact the public key of the original e-commerce site that you wanted to do business with. So, to review, digital certificate comes from the server of the e-commerce site that you want to connect to. It's downloaded to your computer. Your computer will look at the signature included in the certificate. It will also look at who issued the digital certificate. In this case, it was DigiCert. Your computer will go into its certificate store, find the appropriate public key. Well, you find the appropriate certificate that contains the public key of the company that signed the certificate of the e-commerce site. Your computer will use the public key to decrypt the hash of the certificate that came from the e-commerce site. Then your computer will also use the same algorithm to hash the the downloaded certificate from the e-commerce site. And if the hash that your computer generated matches the decrypted hash from that was in the digital certificate downloaded from the e-commerce site, then your computer knows that everything is okay. That the public key contained in that digital certificate can be trusted and can be used to generate the session key that's sent back to the e-commerce site to be decrypted by their private key. And now both ends have the session key, and the transaction between your computer and the e-commerce site can proceed in a secure manner. That's the way it works. And remember, all of these are just really long numbers.